Dear students, after studying this module, you will be able to know the substitution in square planar complex. You will be able to learn about the relationship between the reaction rate and the nature of ligand trans with respect to the leaving group. We will also learn the principle of trans effect and the trans directing series. Eventually, we will learn the theories of trans effect. So, what is trans effect? The trans effect gives the relationship between the rate of reaction and the nature of ligand trans to the leaving group. This effect was studied by Chernev in 1926 to understand the kinetic behavior of square planar complex. The ability of a group to direct substitution into its opposite position, that is also called transposition, is called trans effect. For this purpose, we are going to take an example of square planar platinum complex that is having 4 ligands. Out of them 3 are chlorine and 1 is ammonia. When this square planar system is reacted with ethylene molecule, what will be the product? See, there are 3 chlorine ligands and 1 ammonia. So when this system reacted with C2H4, it forms dichloroplatinum, 1 ethylene molecule and 1 ammonia. It means the C2H4 is associated cis to the ammonia molecule. Reason for this substitution, why C2H4 is attached at cis position with ammonia, not cis to the chloride. The reason being, since chloride ion has greater trans effect than that of ammonia, therefore Cl minus opposite to NH3 do not replace. Rather, the chlorine having the trans effect, chlorine, one chlorine trans to another chlorine. So when C2H4 is attacking to the complex, the Cl trans to Cl is dissociated and C2H4 occupies the position. It means the cis product is favorable for such kind of reaction. On the other hand, if you take the square planar platinum complex having 3 chlorine and 1 C2H4 ligand, and now ammonia is reacted with this molecule, what will be the result? The ammonia attacks at the trans of C2H4 ligand, not trans to the chloride. As I discussed in the previous case, when C2H4 was reacted, it was trans to chloride, while when the ammonia is attacking, it is trans to C2H4. So now in this case, the trans effect of C2H4 is greater than that of Cl minus. Therefore, the Cl trans to C2H4 is dissociated and ammonia occupies the position of the dissociated chlorine ligand. The trans effect can easily determine the formation of products of PtCl4 2- reactions. Let us have 2 comparative studies taking PtCl4 system. On the first case, so it is tetrachloroplatinate, where all the ligands around platinum in square planar geometry are chlorides. When one molecule of ammonia reacts with this square planar system, it leads to the formation of trichloro-1-ammonia platinum square planar complex. Simply, there are 4 chlorine ligands attached to platinum center and therefore one of them has been substituted by ammonia. Now this is again a system, as I just discussed, that it is now platinum square planar complex containing 3 chlorine ligands and 1 ammonia ligand. So now when next mole of ammonia, one molecule of ammonia is going to react with this system, there are two probabilities that where ammonia will attach trans to Cl or trans to ammonia. So the result that gives the conformation is ammonia product form, that is cis to ammonia, means the ammonia ligand, second mole of ammonia ligand has been attacking to the chlorine trans to chlorine, not trans to ammonia, because the trans effect of chlorine is greater than ammonia. So the cis ammonia platinum dichloro complex is formed. It was tried to see whether the trans product is formed or not, like ammonia, second molecule of ammonia is attacking trans to ammonia and forming trans dichloro diammonia complex, which is not evident, and therefore the strongly suggests that the chlorine has greater trans effect power than that of ammonia system. Second probability is that, let us consider a platinum square planar complex where all the ligands in this system are ammonia molecules. So now it reacts this tetra ammonia platinum complex with one molecule of chloride anion. So when chloride anion attaches to this square planar complex, what happens? There are 4 ammonia at the site. So one of the ammonia simply displaced by chloride anion. So now it is forming. On the other hand, like in the previous class we discussed that it was trichloroplatinum monoammonia complex. In this case it is triammonia platinum monochloro complex. So there are 3 ammonia in this case and just 1 chlorine. Now let us have the reaction of this triammonia monochloro complex with another unit of chloride anion. So what will be the product? See, it was found that the trans product was favorable, means the chlorine next second molecule of chlorine attacks trans to chlorine. So in this case the trans product is favorable, not the cis product. The reason being, in this case there are 3 ammonia, 1 chlorine. So the chlorine has greater trans directing power and the ammonia molecule which is trans to chlorine is dissociated and chlorine occupies the position of ammonia ligand, and therefore the formation of trans molecule, trans complex is resulted. The formation of these products are governed by the substitution of ligands in the square planar complex trans to Cl- ion. This is called trans effect. The group that directs the substitution trans to it is called trans directing group. So there is a series proposed by Langford and Gray which finds out that which ligand has the maximum trans directing ability, and this series is like Cn- has equal trans effect power with carbonyl, nitrosyl and alkene. So these are strong pi acceptor ligands, so they are Cn-, CO, NO, C2H4. Now these 4 are having greater trans directing power than that of thiourea, hydride ion, substituted phosphine, and thiourea, hydride ion and PR3 substituted phosphine have equal trans directing power. Now these are having greater trans directing power than that of the iodide and thiocyanate, and iodide minus and SCN, thiocyanate minus, are having equal trans directing power. Now iodide minus and SCN minus have greater trans directing power than chloride anion, and chloride has greater trans directing power than pyridine. It is followed by substituted primary amines RNH2, which is having greater transdirecting power than NH3, which has greater power than OH negative, which has greater power than water. So in this series, the water has the least transdirecting power, while Cn minus, CO, NO and C2H4 have maximum transdirecting power. So let us consider two of the groups X and Y attached to the square planar platinum complex, and rest two ligands are chloride. Okay, so if this system X, Y cis to each other are, and there are two chlorines cis to each other in square planar platinum complex. So here this is chlorine, chlorine is X and Y. Now it is treated with one molecule of ammonia. So what will be the product? See, if the transdirecting power of X is greater than Y, at that case what will happen? The ammonia molecule will attack trans to X, not trans to Y. On the other hand, if Y has greater transdirecting power than X, then the entering ammonia molecule will form the product where ammonia will bind trans to Y, not trans to X. So that way we can synthesize different isomeric compounds in a square planar system, applying the ability of the ligands and their transdirecting power. So it has been observed that the transdirecting ability of ligands such as CO, carbonyl, Cn minus, NO, etc. are higher because of presence of vacant pi or pi star orbital for accepting electrons from filled metal orbital to form d pi or d pi type of metal ligand bond. The pi bonding ability is directly affecting the ability of trans effect. More will be pi bonding ability of the ligands, higher will be the trans effect. Means as the metal and ligand pi bonding, back bonding will be there, the trans effect will be greater. However, the ligands such as water, ammonia, chloride, etc., due to lack of pi bonding ability, the transdirecting ability of these systems, these ligands, governed by polarizability. The higher will be polarizability, more will be the ability of trans effect. So let us have a look about the theories of trans effect. The trans effect is a kinetic phenomena affecting the magnitude of activation energy of the reaction. The kinetic trans effect is different from ground state or static trans effect. This affects physical properties such as vibrational frequency, bond length and chemical shift. There are two main theories which can explain the phenomena of trans effect. So the first is polarization theory. According to this theory, the polarization, that is effect of actually sigma bonding of a ligand, would be directly related to its trans effect. In case of tetra substituted platinum, that is formulated as platinum X4 type of complex, the overall dipole generated are 0, like for tetrachloroplatinate or tetra ammonia platinum. In both the cases all the ligands are same, so they cancel the dipole moment of each other and overall the dipole moment is 0. The dipole moment of PTLX3 means like trichloro monoammonia platinum complex or triammonia monochloro platinum complex. The dipole across the opposite X cancels each other, like this is platinum, one chlorine, another chlorine, third chlorine and ammonia. So the chlorine which are trans to each other, they are cancelling the dipole moment of each other. But the chlorine that is bonded trans to ammonia, this will polarize. Okay, so due to the larger size, L has higher probability of polarizability than that of X. The induced dipole moment of L causes deformation of platinum to center that results more effective bonding and higher bond energy in ligand PT bond. L means like ammonia, then platinum X bond. Let us define X as chloride. So this results platinum chloride bond, platinum X bond trans to platinum ligand bond, yeah, platinum ammonia bond are weakened and longer. The weakening of platinum X bond trans to platinum L bond causes the rate of substitution of X more easily. It is evident that due to higher polarizability, L has higher trans effect than that of X. Like, see, in platinum X4, MX4 type system, metal is at the center and X in the square planar system attached at the fourth different sides. And now if it is LMX3 type of system, so L has greater polarizability. So it is now that the overall platinum complex is not having the trans effect 0. So that is reactive and that causes the trans effect. Greater the trans effect of L results MX bond weaker and longer. Remember, if the L attached to the platinum has the greater trans effect, then it will weaken or it will elongate the bond, that is MX bond. The trans effect of the ligands which are not able to form metal-ligand pi bond increases with the increase of their polarizability. Like a series of halogen group, that is Cl minus, Br minus and I minus. So if you see, the polarizability increases from chlorine to bromine and bromine to iodine. So therefore the trans effect or trans directing power of iodide minus is maximum and Cl minus is minimum among Cl minus, Br minus and I minus. The second theory is pi bonding theory. The ligands having vacant pi or pi star orbitals can accept electrons from filled metal orbital to form metal ligand pi bond. So these are categorized generally either d pi bonding or d p pi bonding. So you must be clear that the d pi orbital is always from the metal side and d pi or p pi orbital could be from the ligand. So ligand could be p block element, so it will be p pi orbital. If the ligand has d cells, so it can form d pi type of bonding. So the example for this kind of bonding is CO Cn minus C2H4 minus, and d pi bonding can be resulted for substituted phosphine spectra. The trans directing ability of the pi bonding ligands increases with the increase of their ability to form metal ligand pi bond. For example, in the case of PTLX3, where X could be chlorides, L could be ammonia and platinum, or L could be X and X3 could be ammonia type of complex, the formation of pi bond increases with electron density on the platinum ligand bond and decreases on trans of L. This results the platinum X bond trans to platinum ligand bond weaker. Hence, the substitution goes like X trans to L. So now consider platinum, it is substituted by L at one end and with 3X at another 3 ends of the square planar system. Now an entering group that is denoted as Y is coming So L is having the more trans directing power. So the platinum X bond, that is trans to L, will be polarized. So the entering group Y will be attacked from the platinum X bond, that is trans to platinum L bond, and it will form an intermediate geometry, that is trigonal bipyramidal. And due to this instability of trigonal bipyramidal system in D8 systems, like platinum 2 is D8, so immediately the weakened elongated platinum X bond trans to platinum L bond will be dissociated, and it will form trans platinum dichloro L and Y complex. The pi acceptor ligands increases the stability of reaction intermediate. As I just mentioned, this is trigonal bipyramidal. The incoming Y enters into the direction of platinum X bond trans to L because of the poor bonding of this bond with the platinum polarized by the ligand, that is called trans directing power of the ligand. So the d pi p pi bond and d pi bond formation is like that. The p orbital of the ligand is overlapping with the d pi orbital of the metal, so that is called p pi d pi. And if d pi orbital of the ligand is overlapping with the d pi orbital of the metal, so this is called d pi type of bonding. So in summary, trans effect gives the relationship between the reaction rate and the nature of the ligands trans to the leaving group. The ability of a group to direct substitution into its opposite position, that is called transposition, in square planar complex is called trans effect. The trans effect of the ligands which are not able to form metal ligand pi bonds increases with the increase of their polarizability. The trans directing ability of the pi bonding ligands increases with the increase of their ability to form metal ligand pi bonding. So that is all about this module.